Hey everybody, this is Larry. This is day 17 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. As you can see, today was not a necessarily good day for me and for this problem. I just kind of struggled a lot. I blame it on the fact that I did a blood donation thing. So, I don't know, something's just not right. But in any case, the reason why this is not the live portion, and you could kind of fast forward and skip it if you like, is that I'm going to do the explanation first for this video. As you can see, it's a very long video. And I did kind of get to it at the end, but yeah, it's just very long. And I kind of went the wrong direction because I misread a little bit. I missed the fact that there are negative numbers, which changed the problem dramatically and make it much different, if not more difficult. And yeah, so okay, so this is a Subarray problem. I think the thing that I kind of talked about is that this feels like a sliding window because, well, we've been giving sliding windows the entire week, and the way that I'd like to structure this is just in the way that if in a window, if you have a left side and the right side being your last element that of a subarray, what is the contribution to the answer? That's the way that I like to phrase it. Okay, I'm going to skip a little bit ahead in terms of explanation. You can watch the rest of the video, but I want to go straight to the explanation because I'm very hungry, and actually we've been recording this for a couple of hours. But in any case, yeah, so the first idea to think about for this one is because of the negative numbers. The negative numbers make things trickier because a lot of the properties that you get with a non-negative version is not true anymore, right? And what I mean by that, meaning that you can think about that in if you're given only positive numbers, adding a number from left to adding a number to make the array bigger will always make the total bigger, and subtract a number will always make it smaller or equal to, right? Monotonically smaller. So okay, but with a prefix sum, spoiler alert, but with a negative number, that's no longer the case, right? And the way that I like to think about it for this one is, well, let's start with prefix sum, right? What is a prefix sum? Well, let's do a straighter line. Let's do an XY thing, right? So this is X and this is T for total, maybe. And you can think about a prefix sum as a line that starts at 0. We go up as we add a positive number, go down a little bit, add a negative number, something like this. I don't know. I'm just drawing it randomly, really, right? And what is a possible answer for this, right? Or like in terms of for this problem, we're trying to find k for some k, and really, yeah. And here maybe you can think about it a sliding window as the left index and the right index, something like this, right? Okay, so maybe this could be your window. And what does the k mean in this context? Well, k means that, okay, given this level, which is the prefix sum up to this point, then the sum of this, the total amount inside the window is going to be this point minus this point, right? The beginning of the left side. So that's L for left, R for right? And we know that, yeah, the height of R minus L is going to be equal to or greater than or equal to K, or ideally, right? Well, so now we ask, and let's say we fixed the right side because, as we said, we're trying to figure out, okay, if right is the end of the subarray, what's the contribution to the answer? And this is the part where the prefix sum and the visualization gets you, is this idea of greedy, right? Well, because now all we are saying is that, yeah, can we move left the left border to the right? And the answer is, well, you can always keep moving it if there's a possible answer in the future, right? A possible answer in the future is something like this, and a possible L is, yeah, if the minimum element, in this case, I needed a better, yeah. Let me re-edit the graph slightly so that this is slightly lower. But yeah, so if there's a minimum element in the future, right? Let's say this element minus this element is greater than or equal to k. That means that yes, you can move to the right because there is there is an element to the right where it gives you a better answer. That's really the way that I would think about it. And this is also where monotonically. So you could do it two ways, I guess. One is with a segment tree, because now you have a range, right? You try to figure out, okay, well, in this range, is there an element in which the index, the delta of the height of the indices is greater than or equal to k? And in a greedy way, you want the minimum element, because if there exists a minimum, or if it's true for the minimum element, then it's true, right? That means that there is an element. If it doesn't, or maybe another way of phrasing it is, if the minimum element does not give you that k difference, then that means that no element's going to do it, right? And of course, in this way, you could do a segment tree on the prefix sum, right, to get the minimum element from the two indexes. Of course, that's one way to do it. Another way to do it is with monotonically increasing q. The way that I call it is the mono min q, or min q in general. You could I have a video on mono qs, a 2-part video, so definitely you could watch that. But the idea there is just to keep an invariant, right? And here, actually, it's kind of a cool way to think about it, since we have this visualization, especially on mono q. And we can pretend this is a little bit lower. But yeah, but is that, okay, so now we're at this point. What is the min up to this point? Excuse me, hang on. Yeah, the visualization of the min is that, well, this is going to be the min from here to here, and then this is going to be the min from this point to here, and then after that, I guess technically this is the min, right? So we go from min to here. So then your min function, your min q, and green is literally the mono min q, is that it looks something like this, because, well, and that's why it's monotonically increasing, because you know that this is the min for this section, this is the min for this section, and so forth, right? And because once you get this line past this section, then it can no longer be true, and yeah, and this is why you have this. And then you have another thing of thinking about mono q, is that, you know, let's say now we move the right side to the let me change the colors again. We move the right side to, say, this index, where, okay, so now this is the new min, and then now you know that this pops off here, so then now you can redraw this to here, and then popping this off. So these are kind of visual ways of thinking about mono q that I want you to think about. And for example, like, let's say you go down here, this kind of just like, it extends, well, and the reason why this extends is not just like a visual thing necessary. It's just saying, okay, given that this is the new min, what is it the min for? It is min for all these areas, right? So that's why you can kind of yeah. I mean, I'm going a little bit fast, honestly, but draw these things out for both the prefix sum and the mono q, and I think it'll give you a better understanding visually of why things are. And it took me a while to kind of get to that point, and then once I saw the prefix sum visualization, I was like, oh yeah, of course, this is very obvious. Maybe, I don't know, maybe to me anyway. But yeah, and in terms of code, let's go through it. Yeah, so here we have q, that is the mono q, mono min q. This is just the prefix sum. I'm not going to go over either of those in more detail for this video, honestly, because I'm really tired. This is a daily video. I spent 2 hours on this already. I still didn't even eat today after donating blood, which I should have. I thought it would be a quick video, but I need to eat. So I'm not going to go over mono's min q or prefix sum for this video, other than the visualization that we already did, which should be a little bit different, because I think, well, I haven't done it anyway. So then here, governing the code, total is just the sum of left to right inclusively, though I don't think I end up using it anymore. Oh no, I do use it, but yeah, but also, like, yeah, total is just the prefix of this thing, right? Because, well, we already did the map, so why not doing it? Here we try to maintain the mono q such that it contains elements from left to right. That means basically, if you have the mono q of a window, once we move to the left, we want to, we just want to make sure that at this point the invariant is that everything inside the mono queue is from left to right inclusively. So anything that is left of the mono queue or left of the left boundary of our sliding window, we just pop it off. So that's why we do a pop left here. And here, this is the key part about it, right? Is that, okay. So now, to prefix Subarray, if you kind of recall from the visualization, this is the top, the current sum that we're considering, right? And then the min is going to be equal to basically the front of the mono min queue, because that's the that's the range that it goes for. So then you have and yeah, and I guess there are a couple of ways to write this actually, but I wrote it this way for another reason, which if you watch the live portion you'll see. But as a result, then now we have this plus 1 minus the min has to be greater, if it's greater than or equal to k. If this condition is true, that means that you can move to the right without any penalty, because 1 is that we know that an answer exists, and also that the answer is smaller, right? The reason why the answer is smaller is because we're shrinking it. So this is going for the sliding window where you're fixing the right side, there is going to be a better answer, and this is basically the reason why. And as we do it, we also pop off the left. Though I think, honestly, this never happens. Now that I think about it. And the reason why it never happens is yeah, the reason why this never happens, unless k is negative or something, I suppose, which it cannot be for this problem. The reason why this never happens is because, yeah, in the worst case, when you remove because, yeah, it is like the previous element or something. I don't know. Maybe this is fine. But either way, yeah, this is a free statement pretty much, so it's fine. And here, we just double check that, okay, now, because with this, they're invariant, right? The invariant is either, well, length of q is equal to 0. That means, I don't know what happened. Maybe things went wrong, really. No, I mean, q could have 0 elements if it's literally the 0 item. Maybe I should, but you could have probably fixed that with actually with a sentinel value of like 0 sum, right? Which I didn't do, so maybe that's why it is a little bit messy looking. But yeah, or in this case, if this is no longer true, then that means we're at the min, right? Is what I mean. Oh, I guess this actually ends when this gets popped, which and this gets popped means that we have a new min, and this min is going to be a little bit higher, and that means that now so yeah, so this does get popped, sorry, but it now means that left is where the min is, right? So I guess maybe I could have written this another way, because we know the index, so we could have just keep on popping. So we can actually maybe even write, yeah, I don't know why I didn't do that way. Actually, let's optimize this a little bit. So then q is equal to 0 of 1, because now we're just moving straight to the min index, right? Oh no. Okay, I see. No, you could. This loop is still necessary because you can have multiple mins. That's why I think about it. Because if you think about the mins, let's say you went to the min, there's k difference, and you're good, you're happy. But then the next min, right? The next min element, if that difference is still greater, less than or equal to k, or sorry, if that is greater than or equal to k, then you want to go to that min. So you want to keep on going to the mins in which, because. Let me bring up the visualization back again. If you kind of think about it in terms of this monster thing, but let me kind of erase this real quick. And yeah, if you kind of think about it in terms of, okay, your mono queue looks like this, right? Something like that, as we talked about, right? And your current thing that you care about is on here, and you just care that you basically try to find the thing in which this is the fewest element in which this is still greater than equal to k, because here it's true that this would be greater than you go to k, but you can also keep on going, right? So that's really the idea behind this. Yeah, that's why I wrote it this way. I forgot. But here, then now left is where the min is, where it is still greater than u to the k. So then now we just do a check for best, and then yeah, and then here, this is just maintaining the mono queue at the very end, right? And maintaining the mono queue at the very end is giving this visualization. Now you're trying to put you know, a new total in. And okay, in this example, the total is up there, but let's say, you know, your total is down here, and that was your mono queue. Then now you want to, yeah, let's say this is your mono queue. Then now you want to trim these things off because they can no longer be the min for the future. So then you're good here. And that's really the idea behind this as well. For the mono queue, I like the visualizations, but yeah, but that's pretty much it. And then at the end, we pop off all the stuff that's not possible anymore, and we put it back in. We set the best as equal to -1 if this is not possible, and then we return best. And that's pretty much it. Maybe make it slightly smaller for a sec so that you can see more of it. But yeah, this is O of n time, O of n space for the deck, O of n time, O of n space for prefix sum. We already talked about this, but each item can only be popped once and pushed once. So in the queue, all the operations are O of 1 amortized. And that's pretty much it. O of n time, O of n space, and that's all we have for this one. A very long one, and I did it a little bit late. My apologies, but hope you still get, you know, you focus on the learning. You know, that's it. But yeah, thanks for watching. Stay good, stay healthy, to good mental health. Oh yeah, I forget. You can watch the live portion next. I'm tired. I'm gonna get food, and I'll see you in a little bit. Hey everybody, this is Larry. This is Day 17 of the Leetcode Day Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. So this one, today I've been a little bit late. We did the night contest, and this morning I had to wake up and I had donate blood, which I guess you can, I don't know if you could see it, but yeah, people always, yeah, I had to donate blood. So yeah, it's a little bit late, but you know what? It's fine, hopefully. And I think I've probably done this farm before, so you could check out that video. Though it's been 4 years, huh? So maybe that video is not that good. I don't know. Maybe it is. But yeah, let's take a look at today's farm. Without further ado, there's only a couple of hours left. We have 862, shortest subarray with sum at least k. Given an integer array nums and an integer k, return the length of the shortest non-empty subarray nums with a sum of at least k. If there's no such subarray, return -1, okay, and the subarray is a contiguous part of an array. This is this is when it was posted, I suppose, was considered a Leetcode hard, but honestly, at this point, it probably would barely make a Q3 anymore. But I mean, this one, there's a couple of ideas here, right? I think first is that, of course, we've been doing sliding windows all week, so you know, like that's a little bit of a thing, right? So we've been doing sliding window all week. That's going to be the idea. The way that I think about sliding window, of course, is I've been kind of, you know, refining it over the years, and the way that I think about it is thinking about, okay, well, you're given a window. If the right side of your window is the last element of the subarray, what is the contribution to the answer, right? And in this case, yeah, and then it's going to be the length, and we're going to try to make it as short as possible. And of course, there's some stuff about greedy and invariance, which deals with greedy, that allows you to kind of fill in the proof, if you will, like, you know, make it concrete. So anyway, let's take a look at this, and yeah, let's take a look. But yeah, so maybe we start with best is equal to -1, right? And then we have for right in range sub n, we have to define n. I usually write it something variation of this, just because then now it allows me to kind of move right one element at a time. I mean, it's not for everything, of course, but it just allows me to then now answer, okay, if right of the sliding window, like I said, is the last element of whatever, of a subarray we could care about, what is its contribution to the answer? So, okay. So then now, well, inside the window, what do we want to care about? We want to care about a sum of k, right? So we actually, here, we have to define this very carefully. And I'm not going to define it quite yet now, because it could be very, Yeah, because I think if I define it now, it's a little bit weird, but maybe not. I don't know. But anyway, so then now we're gonna say we want to add num sub right to the window, right? It is now the last element of the subarray, right? So here we just add it pretty straightforward, and then now, okay, well, what happens, right? The two type of now the window contains this, so there are really two scenarios, right? Which is that total is greater than k, or total is, well, I guess technically greater than equal to, or less than k, right? If total is greater than equal to k, then we know that left, right, the window is a possible answer, right? Because total should contain total contains the sum of num sub left to I want to write it this way, but I guess Python is technically the right bounds is exclusive, so num sub left to num sub right inclusively, right? Okay, so then now we know that this is a possible answer. Can we get a better answer, right? And here, yeah, Oh, this is a tricky one, isn't it? Actually, maybe I made a mistake, honestly. And the reason is because they're negative numbers, because then now it's not monotonic anymore. Because the reason why that we can ask if we could get a better answer is that we can shrink the array, and we shrink the array if we only have positive numbers. If we shrink the array, then we know that the total is going to go down, but the array will get smaller, right? So then now you can do things along those lines, but because of the negative numbers, that's no longer necessarily true, right? You could shrink down and get a bigger number. And also the invariant is that, I mean, I think that's part of it, but this part as well, which kind of adds to the confusion a little bit, is that this part adding confusion is that if, and this is my fault, is that if we add this number, we always, and I got, the invariant, if it was a positive number, is that total would get monotonically increasing, right? It can only go higher. And as a result, then now you can walk down. But now I have to kind of rethink this with negative numbers, because then now, in theory, if you add a number, it can actually give you a worse result. So then now you have to kind of, in theory, if you want there to be an answer where k is the last element, you might have to extend. But maybe that's fine. I think for this one, because we're trying to find the shortest, maybe that's fine. In the sense that, okay, if you have negative numbers, right? And we do, so we have to do it. It's not an if. But so previously, all right, let me just kind of say it in one kind of thing, so hopefully it's more understandable, is that the reason is that the difference between negative numbers and not having negative numbers is that adding a negative number now makes the total smaller, or possibly making it smaller. But as a result, because total could be, well, the invariant is that total is going to be less than k, but coming into this. But now it's going to be smaller. But the thing is that now that it's smaller, if this element is the last element in your subarray, this is why I try, or in your window, what is the contribution to the answer? Well, there's only two scenarios, right? Where, well, this is no longer greater than or equal to k. So then, you know, you already added one element, right, from the previous possible answer. So if you add one element, the only way to kind of make total bigger is by expanding. And because you already fixed yourself to that the right side is being the last element in the subarray, you can only extend left, right? But of course, if you extend left, then that is no longer going to be your shortest possible answer, because you're adding to the possible answer versus the previous contributions. So I think that still kind of works, but it definitely takes a little bit more time to prove. Okay. But yeah, so this is maybe no longer a possible answer because, but yeah, So okay, the invariant that we want to come up with here, let me be a little bit precise, is that total is going to be less than k exactly, right? The loop invariant. And the reason why you can say that is that the reason why this is the case is that in theory you can say that because total is again the sum of what or this stuff, right? Is sum of num sub left to num sub right, inclusively. So that means that in most or in scenarios you have to, with conditions, then num sub left minus 1 to num sub right inclusively is going to be greater than equal to k, right? That's really the idea that we want to go for here. Yeah. If it, I mean, this is not in all scenarios, but in scenarios where yeah, left is greater than 0 or something like this, right? Or left minus 1 is greater than equal to 0, right? Because then now, yeah. Yeah. And yeah, we want to add to the window. Now it is the last element in a possible answer. Okay, so there are two cases, like we said. I mean, we did a lot of talking, but turns out it didn't really change anything, which is great, I think. But it only applies to this one because we're trying to find the length of the shortest subarray, right? But yeah, left to right window is a possible answer. Can we get a better answer? And we can try to get a better answer. So maybe you could even write best is well, we have to write if right. If this is the case, then now we can do like best is equal to max best right minus left plus 1 for the number of elements, right? Because at this point it's still left to right inclusive. Yeah, and then now can we get a better answer, right? So yeah, so then in getting there, then while left is greater than equal to right, we do left increment. And of course, total is greater than equal to k, right? Yeah, and technically you can put the loop here as well, or put the loop here, right? And also technically as a result, because this will increment, or it could keep on getting smaller, shrinking, so you'll actually only have to do it once at the end, right? Except for that now this is post the left plus 1 plus equal to 1 increment. So here the invariant is two things, right? One is that total is now less than k, so we are counting, or we should consider to left minus 1, right? So then now it's going to be right minus left minus 1. So this is going to be this plus 2. I think so. Maybe I'm off by 1 still. I'm a little bit awkward, but yeah. Yeah, right? And then, so that's the case. Else, then we just kind of move on actually, right? Because if total is less than k, then yeah, to make it greater than k, you would actually, in theory, if this is consideration, you would extend to the left as we said, but that will give you a worse answer than even just the previous without this current number, so that's why we don't do it. So I think that's mostly it. We pass because to get total greater than k, we have to add elements to the left, and to prove why this is the case, there are really only two case analysis, right? One is that the case analysis is that previously left minus 1 to right inclusively is greater than equal to k, and if that's the case, or maybe yeah, I think technically this, right? So not including the num sub right. So if you kind of do something like this, then well, that is already your best answer. So if you change your index to left minus 1 to right, that's going to obviously be a longer subarray, and you still have to increase, right? So that means left minus 2, but that means that this subarray will be longer than this no matter what, even if it's greater than or equal to k, but if it doesn't, then you know. And then the other case is that the other case is that left minus 1 to right inclusively is less than k, right? And then this is kind of the same idea, really, is that you have to keep on adding numbers to make it inclusive. So then, yeah, that's going to be bigger. I think I said this one. You have to keep on adding numbers, so that's already going to give you a bigger array. So in those cases, 9 of those cases will give you a better answer, and that's really the way to think about it. I think maybe I'm off by 1, but hopefully not. Okay, well, it looks okay here. I'm just going to YOLO submit because I'm lazy. But and I got the wrong answer. Was it the same wrong answer as last time? Nope. But yeah, okay. Let's see what Larry did. The -1 is definitely very confusing. But so I put 3 expected 2. Okay, so that means that my answer is worse than it can be. What is the K? 140. Did I just do the math wrong? Because this should be 140, right? So why? Maybe I did the math wrong. On this one, nope. Okay, so that was my first intuition, but okay. So 48 plus 99 is 140. So I'm trying to figure out. Okay, so total is gonna be 48. Doesn't do anything, and then second loop it adds, and then now it's gonna be So then, yeah, while left is greater than equal to k, and total is equal to this, right? So then now we subtract left and increment 1, so then left is going to be equal to right, both at 1 index. This is going to be 0 plus 2, so why is it giving me 3? Oh, I am just dumb, am I? We're trying to find min, but I have a max here. I'm just being dumb. I think the reason why I did this is because I had a -1 here. I wasn't thinking through it. We're trying to find, we're trying to find min, Larry. Why are you trying to, I think it's so that I don't have to write this if statement, but then I just messed it up as a result. I'm just being really silly. So yeah, let's give a quick submit. Oh no, too quick of a submit apparently. Alright, so apparently, this is a very hard problem. Maybe I misunderestimated it. Okay, so here, my output is 5, we expected 3. Yeah, 135, 167 exactly, right? Yeah. So why am I doing it wrong? So at the last element, it's gonna have these things. Oh, I didn't miss a case actually. That's tricky. Is that as a part of this analysis, I didn't miss this because here what I said assumes that. How do I want to do it? What I said here assumes that that subtracting an element or removing an element from the left will give you a smaller k. So that's why we never consider it. But here, as you can see, this is the window, and here we actually want the window to actually it's even more than that, right? It's actually. So okay, so what this is saying is that okay, so you have here, right? Apparently, signing window problems are hard sometimes. But yeah, so this is your entire window, and the reason why you may want to consider a smaller window because the thing is that subtracting things will never give you. The idea is that when you remove numbers, it will give you a smaller number. No, but here, that is, what is wrong here actually? Because that should be, okay, so it goes to 40, right? 70, yeah, actually it should go to all 5, but then now it should shrink, right? Oh, no. Well, it goes 1 element and then, because the thing is that I don't know why this is 5 though, honestly, but yet because it should shrink 1 element, and then I guess when you shrink 1 element, you have this, and this is less than 167. So then now it does the +2 thing, which is then now you have all 5 elements. Okay, I think that makes sense actually. but yeah, but that goes to the thing, right? Is that here? So this is the window. It goes, okay, this is bigger than you go to k, so it tries to shrink to negative the 84. But now this is going to be too small, so then now it does the other thing, right? But the thing is that we have to figure out how to make it so that we want to subtract this again. Maybe I'm just really bad at this, apparently. Will we ever need negative numbers? I think you need to do one more proof, which I'm trying to do in my head, which is the stuff around negative numbers. I mean, we can definitely special case negative numbers, but definitely at the top. But I feel like I don't know that that's all the possible thing, because you can say that, okay, well, if the left of the window is negative, then you remove it, which, okay, fine, that makes sense, right? And in a greedy way, that always makes sense. You always want to remove the thing. Yeah, I think maybe that, I don't know if that's sufficient, right? I mean, I think that's definitely a thing, but I don't know if it's sufficient enough to be right. But okay, let's just try it for now. Yeah. So you have this, and either total is less greater than your k, or num sub left is negative. Because if it's negative, then you can always just subtract elements, right? To kind of keep going. But then now this thing may be wrong, because then now like this may no longer be true. This invariant is no longer necessarily true, because you can imagine, like, I don't know, you have a like negative 100 and then a 1 here or something like this, and then so you remove this to get a bigger number. Maybe that's fine. I don't know. It is very hard. All right, let's give it a spin, and then we'll gauge from there. All right, it's already in here. Okay, so it's still wrong. Oh no, it's wrong for something else. For the third case, which is this one. So I put 2. Yeah, I think this part is wrong now. That's why I'm a little bit but that's fine, actually. I mean, it's not fine, but we can actually, this is easy fix. We kind of optimize this into it like here, but here we know that the condition is that if total is greater than or equal to k, then we can just do best of min, best right minus left plus 1 inclusively before we take out the math, and that would probably be fine. But let's give it YOLO submit. Yeah, I'm not surprised that this isn't right. A lot of the negative situation is definitely something that I clearly underestimated. Underguesstimated. Okay, so here we think the output would be -1, meaning it's not possible, but the answer is 3. Why is that? So we have 89. What happens here? So this is 89. What is our sliding window things? Okay, we have this, right? So then we subtract the negative. So we have 81. We start 81. We get 61. But then we should get 3, right? Why is that wrong? I mean, okay. So now let's print some stuff out then. So we have left, right, total, and maybe just the input so that we can see, separate the test cases a little bit. Okay. So here we have 0, 0 is -28, 0, 1 is 53. Oh, I see. That is tricky. Because I put this here because I just wasn't thinking. We should always yeah. I just wasn't thinking. And what I mean by that is that we put this to kick off only if total is greater than or equal to k, but actually we should do that even if it's less than, at least the negative portion of it, right? So I think we just remove this part as a result. Yeah, and it really, yeah, because you always want to do this, I think, in a greedy way. You submit so many wrong answers. Today's just one of those days. Honestly, I'm a little bit hungry, so I'm probably am rushing a little bit. But yeah, so now this answer is 4, which 4, which 4 do I think it is? And 2 is just 2 adjacent numbers, which is probably these 2. That's hard to imagine that that could be it. Like 51 should hold on, right? So alright, let's take a look at the print statement again. Okay. So here we have 1 0, which is a little bit awkward. But that's fine. It just means that we ignore the first number. And yeah, total is 0. 1 1 is 37. Okay, 88. Okay, what do we want it to be? Oh, I see. Then that becomes small, and then by the time it goes to, okay, 0 1 2 3 4 5 6, so this is the window. Let's actually copy and paste this. So it thinks that, oh, I already did it, but yeah, 1 6, so it thinks that this is the window inclusively, and we have to basically get rid of all this chunk. Was this a no? So then how do I do it? Okay, so what happens here is that, okay, so adding this goes to 27, right? So this in total is 143, which is actually less than 151, so that's why it never triggers off, even though in theory you should remove all the way up here, right? How does that happen? Is this not negative? Oh, maybe that's the thing that I needed to do before the 50 is 29. Well, it's not even negative, right? Because this is I think another way of thinking about it is kind of just oh no, actually maybe I need some pause. Because the idea here is that, because this prefix is not even negative, it's just that this prefix is not the shortest, right? That is tricky. What is a negative? I have to think about this a bit. I think I'm just very wrong today. Okay, so because basically the idea is that, okay, so we have this thing, and in theory we want to pop off all these things, but there's really no good reason to. Well, I'm trying to figure out like a general way of writing that. Man, I am really bad today. But I'm what is the invariant, right? And that's the trouble of the negative number, that as soon as I saw it, I thought I was like in trouble, honestly. I was like, whoops, I think I missed. But well, okay, so yeah, 51, right? But then now if you add to the 100, oh, the tricky thing is that, no, here, okay, so here this is definitely greater than, because this one is greater than. right? So then now minus 37, but the thing that now is then now, okay, so then this amount is negative, is what we have to figure out, right? Because then now we have, okay, so I see. So that what I thought was the issue is, because at 51 you don't need to pop off, because maybe you just need it. But 100 here, then now it removes the 37, and then after it removes the 37, it has only 143, which is smaller. But you can actually do a subtraction by positive thing. But how do we know that that's going to be good enough, right? Like, how do we know that we could keep on subtracting? Like in this case, we can. But what is the idea here? So okay, so we know that this is greater than 151, right? As a sum. So then now we subtract a number, and we know that. So then here, the form is that this sum is less than 151. How do we determine that we want to keep on popping, right? I don't know that you can. Okay, so what is the invariant that would allow us to do it? Because the problem is that, like, I'm trying to think of a greedy way of doing it, which is why maybe it's wrong. But the problem is that you can imagine this number be greater than 151, and then in that case, you do need all the, like, this only gives you a minor contribution of like 5 or something, or what is it? I don't know what it is, but yeah, maybe a little bit more actually. But like 25, right? So it gives you 25 extra. So if this was like 176 or whatever it is, I don't know, I didn't do the math. Then you do need all of these, and you can't really remove up to here. But now, because it's 151, we go, okay, well, look, 7 elements is a possible answer, right? So we're happy-ish. And then now we have 6 numbers, but then now it's less than 51. But then we actually, it turns out that there's a 2 number thing that should be good, right? I mean, the reason why I'm struggling a little bit also, just to be honest, is that I'm trying to keep everything within the same framework. I think there are ways you can make this a lot easier, but yeah, by like using prefix sum and stuff like that. But I'm just trying to think whether I should need it. I think these kind of DPs I always find a little tough, maybe, but. Yeah, I mean, I think okay, let's just, I guess, yeah, I mean, there's no way around it. Maybe we do need something a little bit complicated. It is what it is sometimes. I just am trying to think whether I need it. But okay, so anytime you see a subarray thing and you're thinking about, that we need the sum, it's really just going to be a prefix sum, right? So okay, and the reason is because then now we could do a query on this or something like that, and we'll do the math in a bit. But the idea is just yeah, I mean we just have to do prefix sum. I thought I could do something with the invariants, but I was very wrong on this one. I mean there is an invariant component, but yeah, I mean yeah, I don't know. Here's what it is. So yeah, the prefix is equal to 0, right? So for x in nums, prefix we append x plus prefix -1, right? So now we have the prefix sum. This is pretty straightforward. I'm not going over the prefix sum that deeply today because I don't know. I'm already half an hour in and I'm a little bit tired. But yeah, it's just prefix sum. And then now here we can say, okay, we can do the math, right? So we have the left window. So we know that this part is going to be greater than 151 as we have here. So we have the sum of all the things up to here, right? And then we want to know what is the largest index. How do you phrase it? In which, okay, so for example here you have some prefix sum, right? Let's just call it f sub 7, whatever, for inclusive, and then f of, or p, maybe p of 7 minus p of 0, because we got rid of the -4, is going to be greater than 151, right? And then now we try to, what are we trying to figure out? Well, we know what p sub 0 is, right? So then we add p sub 0 on both sides, right? And we know what p sub 7 is, right? So then now, oh wait, so then actually another thing is that now we're trying to figure out some p sub I, which is also 151. And we know what p sub 7 is, so we have this number minus 151 is greater than p sub I for some I, but we don't need, we're trying to find the maximum I, and not, we don't have to maximize this number, we're just trying to find the maximum I, right? So what do we, can we use this to binary search or something? Let's see, let me think. I'm just so tired. Okay. So then now, it's either that or something like there exists a number, like if we check with 0, then we could keep on sliding kind of thing. I think those are the two things, right? So that means that if that means the other idea is that there exists maybe I need something even more crazy, but okay. I mean, the way that I'm thinking about it is that, okay, so I has to be you know, left and right? So then now maybe we can say, and this number, or does there exist an I between left and right, where, you know, I say 7 because that's where we're at. P sub 7 minus 151 is greater than p sub I for prefix I, right? And of course, in this formula, in a greedy way, you always want to minimize this, right? So then now, because if it's true for the smallest number, it's true for all the numbers, right? So then now you can ask, is there okay, get the min element between left and right, and then you just check against that, and for that you could use like a binary index tree or something. I'm probably overkilling it a bit, honestly, and but yeah, I mean, actually, Oh, my code is a little bit awkward. Okay, fine. Trying to find my binary index tree code. Definitely doing this way crazily. No. Yeah, okay. I don't know why my server is going issues and doesn't give me the binary index tree. Okay. Just give me the cached version. This is very annoying. I don't have my code on me. Oh, I guess I could have just asked ChatGPT. I forget. Give me bit in Python, please. But yeah, again, I'm not gonna go with that. I think today I'm not going with that much, and that's, I don't know, my fault. I just gave butt, and I haven't had lunch after that yet. Right, so this is binary index tree, right? And in this particular case, this is going to be the sum. We don't want the sum in this one. We want the min. So yeah. So here maybe we set everything to infinity. Infinity. Right. Yeah, and we only update. Yeah, I think this is right. Okay. Prefix min, say, right? Oh wait, no. What am I doing? This is the prefix min. I confused it because of the prefix sum. I'm just really bad today. Sorry, friends. What we actually want though is I mean, in theory, I think what it seems like we actually want is a segment tree, but I'm hesitating for a sec. I am just very exhausted today. It turns out. Lucky I didn't do this last night, I suppose. But I definitely did not do this with segment tree last time, so I'm just trying to figure out, like, yeah, but it can be done with segment tree. It turns out, I think, is what I'm trying to say. Does it? This is the idea with prefix sum. Can I do it without prefix sum? I feel like there is an invariant that I'm missing for this problem, because I don't think that this is whatever, but what is K again? Oh. Sorry, I'm just trying to think where the segment tree should be the way to go. Apparently I am just struggle a lot. Why is this small? Sorry, give me. I mean, this would definitely be right, honestly, but and maybe for a harder problem, this would be good. But I'm just trying to figure out things from a first principle. I think something's like really went off at some point, but. So if this is the case, right? Prefix sum. We want to get rid of this if the prefix is negative. Is that right? We get the sense that this would be negative if the prefix sum of, well, this is negative for sure. Okay, so here we have 3 chunks, right? We have so if this is 151 and we subtract a number, so then this is less than greater than or less than 151. So then now we have to figure out what is the negative chunk. And the negative chunk, let me look at the prefix real quick. I am too tired for this one. So yeah, right. So the 46 and 146, but then you have this negative 5. So it's just maybe checking that there's a negative chunk. Because if there's a negative chunk, that's definitely the no, I mean, yes, but okay, so that means, what does that mean? Right, so 46 and 57, that's also no bueno, or 46, 54 even, really, because that means that there's a negative chunk. So then now, I think that's the thing that I was looking for. I was trying to find a way. But okay, so then now, okay, let's say we have from 1 to 6, right? So you go up to here, and you know that this chunk is negative. So then now you go to we're kind of okay. Doesn't give us the answer, so we add 46. Oh no, this isn't 1 to 6. I forget that we have an offset. So 1 to 6 is actually here. Okay, so we have here. Okay, so we're good. We're too small, but so we get one more, right? So we're 146. Okay. Maybe I should go back to sleep. Okay, so yeah, so 1 to 6 is going to be here, and let's just do 1 to 7 because this is the relevant part that I'm trying to break out. Okay, so then here, so this sum is going to be, I guess this is just less than. I know this was greater. Oh no, it needed to include the 37, which is actually from the negative 34 part. Okay. Maybe that needed to be in there, maybe. Okay, so here, so 146 minus 34 is too big, so that's good. We know that this is a possible answer. And then now, we try a little bit smaller, so we have this. This is no bueno. But then how do we know to remove this chunk, right? Because this only has 51, so we move 4 numbers. Why are there 5 numbers in the okay. So you have 3. So you have to find the next number. So I guess so there's a negative chunk if okay, so this is 3. But so we need like a mono queue, I think. That's the thing that I was kind of missing a little bit. Is that we know that the min in this queue, we know that the min is going to be -5, and because now, okay, I see. We need a mono queue. I mean, that's kind of what, honestly, this is also the same thing as the thing that we have here, but now we're doing it with mono queue instead of segment tree, which I don't know if it's right, honestly, still. But because the idea here is that yeah, I mean, this is the same idea that we've been talking about with the prefix sum. So then, okay, yeah, because then now we know that the negative chunk exists, so then we can remove to the negative chunk. And then once we're left with this, we should be Gucci, right? Okay, so now we have to add mono queue, right? So okay, so we have the prefix. We want a mono queue, right, on the prefix. Okay, all right. Let's think. Yeah, let's do this again first, right? But I mean, all this is actually technically the framework is right. I think the thing is that we have to kind of boil it down, which this is a very long video for, but hopefully is a good enough thing, right? So here P7 is the prefix sum, right? And we know that we know that this is true for this one. So then now we want to see if there's another case where this is the case. So then we kind of just do the math. So then now we have to figure out an I such that this case is true. And if this case is true, then we just get rid of things before it, because then by definition, yeah, by definition, if you remove that chunk, it'll be basically gives you a negative result. So then you can, in a greedy way, remove it because it gives you a better answer, right? Okay, so then now, yeah, so then now we have num Subarray, right? We can say total still added. And that's going to be the prefix anyway, so maybe total is just equal to prefix of y plus 1 or something like this, which is okay, fine, right? I mean, we already did the math, so why not use it? And then now we want to say, so we have a mono queue, right? Monotonically decreasing queue. Is it decreasing? It should be decreasing. No, it should be increasing, because if you have a smaller number, then it'll pop everything off, right? So, yeah, maintain a mono queue, right? So then queue of the smallest element and index, right? So here we want to say, so then now our current pair is going to be the total and the right as the things, right? And now, so the way with monoq, the way that I always think about monoq, and I have a video on this, is just thinking about the invariant of the monoq itself. And with the monoq itself, what you want to do is that you want to maintain the min element, right? So I call it the min q, which is a little bit confusing versus min heap property, but min q. So to maintain min, you look at the range of possible answers for each index and for each number. And okay, so that means that if you come up with a smaller number, then you are going to pop from the right, because then now in the no. If you have a smaller number and you have a window, then what happens, right? Then now you just pop all the way from the right, because going forward, that number will always be smaller than the previous answer, so then those answers do not become possible. Yeah, okay. So then now, q dot, I guess we don't want pen, but while length of q is greater than 0, and q of the back is greater than or equal to total. The reason why the equal than or equal to is because if it's tied, you want the later index for tie breaking purposes. So yeah. So then now q dot pop, right? So then now we can append total, right? Afterwards as the smallest element from left to right, right? Okay, so then now we have a min q, but we probably actually, this should be afterwards, because we don't need to consider the total yet for this, right? What we now want to do is, as we said, so now we have a total, we want to know if there's a left eye and right? So yeah, so the smallest number between left and right, and maintain q such that it contains elements from left and right, left to right rather. And the first index is going to be 0, so then while length of q is greater than 0 and q of 0, 1 for the index is greater than left, then we pop left because we just kind of pop it off, right? And then now q of 0 of 1 is going to be the min element. No, it's going to be the min index, sorry. So if this min index, so while, so with prefix of left is greater than the min index, that means that there is a prefix sum going from the left side to the min index. That means that it gets smaller, right? That means that it has a chunk of negative value. So maybe while this happens, left increment by 1. And that's only if length of q is greater than 0. Yeah. Something like this. And then now we can check whether if prefix of right, this is off by 1, I think. This is off left plus 1. Okay, so then now if this minus prefix of left plus 1, no, left, because we want to be inclusive. Maybe I'm off by 1 here, honestly. Then we just update best. And maybe we're Gucci, or at least on the same right idea. This index out of bounds. I didn't think I have to check this, but maybe I do. Okay, I mean, that's fine. We're trying to figure out how to learn here. So I wish that this is easier to view. Okay, so I put So this is only the, okay, so here I put -1 even though it should be 3. Why is that? All right, well, let's take a look. Let's take a look. I think I prefer it to be this. And then let's take a look at the queue, right? Ship 8 first. Okay, so you have 2 1. So you have 0 0 because we're processing things, and then after processing the first 2, after index 0, we're good. And then 1 1 1 is going to be the smallest number inside. So that's going to be okay, right? And then after getting the 2 is going to be bigger than that, right? So then what is going on here? Let's see. Okay. So then we have 3, 3, and 3. So prefix, I mean, I should print out left and right, I guess. Yeah, left is 3. Right is 2. Why is this always true? Prefix of left was okay. So right goes from 0, 1, 2, and then left just keeps on getting bigger for some reason. Inclusive anyway, but so 1, 2, so 0, 0, right? The Q is, so the Q is 2 and then 0 for the prefix. Maybe I have to take a look at this part actually, honestly, but okay, so it puts the 2 0 because this is just by default. Right, and then and this part just pops things off of left getting bigger, right? So left, why is left at 1 already? Is this part right? I think that part is wrong. Basically, it's saying that if a smaller element exists. Oh, I'm dumb. This is on the index, that's why. Okay. Alright, I mean, I don't know that this is right. I mean, it should be right, I mean, this is obviously the wrong answer, so maybe I do know that's not right, but yeah. Okay, so at least it fixed for that one, but then now it gets some of the other ones wrong, which is fine. Maybe. Right. Okay, this the last one is this one. It's a little easier to debug. Okay, so then now let's see. Right, we have this number. After one element, we have -28 and index 0. Okay. -28 is going to be okay. So left, right, we have 0, 1, 0, 2, 0, 3, Okay, these are very small numbers, but okay. 0, 4. And then then this never happens. What is the answer for this one again? I think it's -1, but it should be 3. It should be 3 because it should be this 3, right? So then, yeah. Do I need it? I mean, this is clearly a thing, but okay, so 0, 4. So -28 is the smallest thing, but maybe this should also be if. Yeah, I think like I almost want to pop this if this is negative, but I'm trying to double check in my mind whether that should be true. I'm just really struggling today, I suppose. Okay, so what are the states here? This is just also very kind of hard to read, but it's fine. Okay, so basically it just doesn't, well, I mean, it maintains a thing, but okay, so that means that from 0 to 4, I think this math is a little bit off. Prefix, so A right minus, so it's this minus this, 32, right? What is left? Left is 0. Is it left or left plus 1? I think it's left plus 1. Maybe that's why I was doing a bit off. Okay, still no good though. Man, today I just don't have it. I don't know why I'm struggling so hard on a font that should not be that hard, but okay. Some days you just don't have. Okay, so what am I doing with this -28? Okay, so K is 89. So this will never be until this gets popped. I think that's the thing, right? Is that okay? Well, and this part is very weird because I feel like this should be. Oh, maybe now I don't need this because before I kind of was wondering why I needed it, but I think it's just the invariant things because well, it was just comparing it versus the index. So then now I think it goes to the right place, but the prefix. Maybe it's equal to. If it is equal to min, then we do pop, I think. Do we? And is it like this, maybe? Because this would get rid of itself. I think that's the biggest thing. Maybe I do need this, but for now. Okay, so this is gonna be issues with a lot of problems. Okay, just the last 3 cases, which is fine, maybe. Okay, so we still have -1, meaning that they think it's impossible. And I'm trying to find the logs. Okay, so we do have some goodies on the. It does seem to. left, right, Q. Well, this doesn't get popped, so it's not even what is this? What is this? I think this needs to be a thing. Prefix left is right? And then is that right? Yeah, no, I mean it should be right. I don't know if this part makes any sense. Clearly that's not enough. Don't fix. Nope. Why is the Q not popping left? Am I looking at the wrong thing? Okay, so the min. Okay, so let's say we do a 0, 0 thing. But in this particular case, it would pop it off anyway. So it would pop it off. And then now goes left, right. So as we increment left, I think what I need honestly is a refresh, but just start over. But okay, what is my invariant? That's what I always tell people. So maybe now I should live up to it. Okay, so here Q sub 0, 0 should be yeah, okay, and then here. What am I trying to do here, right? All I'm trying to say is that if maybe this doesn't make sense. What I want is that I think I missed some parts here because what I said was that oh, I deleted that. Oops. But what I said was that it was like P7, the prefix of 7. So then it's something like actually yeah, I think that's the part that I wrote out, but then it's something like P7 minus some P sub I is greater than 150 or less than 151, right? So then if this, oh no, it was the other way around. So we know that this is true, or should be true. Right, so then now we're trying to figure out that, right? So then this is the min, right? This is the min of the window. So then now we have prefix sub right, oops, plus 1 minus it's not left, it is actually k is greater than or equal to min, then we want to pop left, well, change left, right? And then if left is greater than Q of 0, 0, 1, then we pop left, right? Maybe that's more right. Is it more right? I mean, it looks more right. I mean, there are other problems with it, but fewer, so it's only the third one. Okay, I don't know how I forgot about this. I wrote this and then I just forgot about it, and then I just kind of, I don't know, went by vibes and feels, which is not great apparently. So, okay, so it's the third last example. So it's this one, I think, right? So I put 5, it should be 3. I vaguely remember this one. from last time, right? 5 and because basically you have this number, and I forget what the k is. Yeah. 167. So then now we have this number. 84 is the min, okay. 47 is the min, okay. 79 is the min, okay. 119 is the min, okay. But then now we have to go to 4. 0, 4, 214, and we're happy. Kind of, right? So we have this, but then now this, I think the thing is that this is not a negative chunk. It's just not necessary, right? Because this is the answer, I think. And even though this is not a negative chunk, I would. Okay, let's put in preview. Okay, so this is a different example, maybe. I have to kind of understand this a little bit. Because I thought you could get rid of just negative chunks, right? But here, this is the prefix sum. So then you have 47, right? I should still... It knows that there exists a chunk that's inside. Right? Because 214 minus 47 is 167, which is the input, I think. Yeah. So that means that it notes that the min... Oh, no. This... Well, I mean, something wrong went here, right? Because then it got rid of the Q. Okay, so I mean, that's a easy fix. With this part. So total. No, this is if it's. This is pop, right? Right. Okay. So if the. So you have 47. Okay, so slow down, Larry. You're always slow enough, so why not slow down more? Okay, so you go from Q, it goes up, so but this is wrong because it's higher. It should not pop this, right? So Q of -1 of 0 is total, should not be. So I pop for some reason. Maybe it's this thing. No, that doesn't make sense. My left is still 0. So what is popping here? What is popping here? And this doesn't make sense, I don't think. Alright, let's try to print. Okay, so then now before the pop, it goes to the 47, which is fine. But then now it's empty. Why? Did I have something weird? So left. Oh, this is just wrong. Whoops. It should be that if left is greater than that, then you pop it out. I am just really bad at it, apparently. Okay. I just don't know how to code anymore. I get basic things wrong. Alright, well. Oh, wow, that actually worked. What did I do last time? I guess last time I was much smarter. Watch that video instead, I think. I mean, this code is so much cleaner last time. What did I do here? Oh. I don't know why this time limited, but... Yeah. I mean, this code ended up being really short, but I mean the key thing is just yeah, the key thing is just I'm really tired. But this is a hard one. I really do want to explain it a little bit, even if no one ends up watching it. So if you're watching it up to this point, let me know in the comments. I'm going to just draw some things to kind of explain it a little bit. You know, and in the future I might not do it if people don't leave a comment, just because I don't know that this is worth me doing an hour and 18 minutes into the video. I don't know if anyone watches it this far, but yeah. But the idea here is just build up prefix sum because of the negative numbers. Actually, as we said, if there were no negative numbers, which I kind of missed, and I was trying to adjust for it, but it didn't really work, right? But now that we have negative numbers, then the idea is that you can think of a prefix sum really as a line, right? So this is your terrible line. This is your y, this is your x, and you can think about the prefix sum as starting at 0, and then it just kind of goes up, down, I don't know, something like that, right? As the sum. Pretend that it's drawn a little bit better. Okay, right? Let me make sure that it's on the screen. Okay, because that'll be. I've done. If you watch this enough times, you know that sometimes I just kind of not show it on screen and just keep talking. But yeah, and then now the idea here is that, okay, well, look, let's say we are trying to figure out, so we're trying to figure out some k, right? And how do you get this k? Well, how you get this k is just not necessarily, you want a sliding window, you want a left-right thing where, let's say this is left and this is right, then it is basically the height, right? The height difference between here and here has to be greater than k, right? Or equal to, I suppose, right? And then the question is, okay, well, if that's the case, how can we minimize the left, right? And the idea here is that knowing that, okay, well, well, what happens, right? So here, the idea is that, okay, so this is left, this is right, and the idea is finding, in a greedy way, we know that we want to minimize r minus left, right? Let's just say, left and right is r and left, right? We want to minimize this. So what we're saying is that, okay, given that we're going to fix one thing, which is, let's just say, the right side, because that's how we do our sweep. We want to see that if there's if we can shrink left, right? Can left go this way? And the answer is that, well, because we have this greater than or equal to k, we know that we can go left if there is a lower dip in the future, right? And that's really the idea behind how this is coded. And there's a lower dip in the future, and we kind of maintain this with a monotonic queue by by basically saying, okay, well, what's the min? And you can think about monotonic queue in different ways, right? For this one, let's say the green line's a monotonic queue, then here, the min is going to be here, right? That means that this is the span in which this is the min, and then this is the span in which this is the min, and then this is and then it goes all the way up here, right? Because then now, this number is min all the way up to here, right? And if you kind of look at this, so the green line is actually the monotonic queue, and the monotonic queue is, as you can see, monotonically increasing because you're always trying to get the min, right? And if you, and for example, if you actually move the blue line, which I kind of do, here, right, to the next, to here, say, right, then now this is where you pop off, because then now you have this new line, and then you just kind of ignore all the other stuff by popping them and then go all the way here, right? So that's kind of the idea behind monotonic min q, right? And so now, given that you have monotonically min q, and the min is always going to be on the top, because otherwise, it gets popped off or queued off, is that it's just knowing that, okay, well, there are bottoms on this, right? And if there are bottoms on this, then we can keep on going. So yeah, that's really the idea. I'm going to re-record this, I think, a little bit, or the explanation point put in the front, or just maybe edit it around, I don't know. But Yeah, and then so basically, as long as we know that there's going to be a lower bottom in the future, then we keep on moving from left to right, and that's really the idea that we have for this one, to kind of make this smaller, because we know that, and we know that if there's and this actually doesn't even have to initially have to be greater than or equal to k. It's just that knowing that it can get bigger in the future means that almost like a, what's it called, intermediate value theorem or something like this, like that kind of idea, is that knowing that it can get bigger in the future means that you should keep going. So that's really the idea. I'm going to redraw this, so you maybe find you won't watch this, because I'll recut it so that's in the beginning. But yeah. And now with that in mind, we could go over the code a little bit, and yeah. This is just to set up the prefix sum, and this is the yeah, and then everything just kind of, you know, maintain the queue so that we pop things off from left to right, so that we pop this one, we just pop things off from the left, so that, because we know that well, we're just trying to keep it from left to right, and this index is already not inside the bounds, right? Yeah, in this case, we're just going from left to right, and actually I don't know that I need this anymore. Maybe I don't, because this the other part should be an invariant. Yeah, I mean that was always a smell that I kind of figured, but and in theory, yeah, I mean I think this is fine. But yeah, but basically this is saying that this is the min element. Can we go to the min element, right? Or is there a min element in the future such that this thing will be true? And we kind of did this formula a little bit, so yeah, right. And if this is true, then we can keep on going to the left and hopefully build that up. And we pop it if it goes outside range. And then now, now that we're at the, we should, because this loop ends either when there's no elements left in queue, which is when left is equal to right or something like this, or, well, this is true. So if this is true, if that means that this is true when you're at the minimum element, right? And so this is, yeah, to keep the left and right element inclusive, I just kind of do a check here, because you might not, because of the length of the equal to q is equal to 0 case, I think. And then at the end, we push total right into the result, and as a result, we pop off the things that are smaller going from the back, right? And that's really the idea. And this is going to be O of n, O of n, O of n, a lot of O of n's, but they're all total O of n because we just have a constant number of them, and O of n space. And that's all I have for this one. Let me know what you think. I don't know why this took so long. Thanks for watching, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.